The first thing I wanted to talk about was coordinates. So, what is a coordinate? It is a representation of a point in space used usually on a grid. So in the example of these 3 and 5, we take our x-axis to be our first number and our y-axis to be our second number. And so this is the x and this is the y. So we're going to go a 3 across and then 5 up. And we're going to mark that with an x. The red one, we're going to go 4 across and -2. So we're going to end up in the bottom right hand quadrant. The blue one, we're going to go -5, so left 5, and 3 up. So we're going to end up in the top left quadrant here. And then the green one, we're going to go -1, -1, and we're going to end up in this quadrant over here. It's not the best x in the world, I'll do it a bit better. Up there. So it's going to be -1, -1. And we've got 4 different coordinates in 4 different quadrants. Recognizing what the quadrants are can be useful. So this is positive x, positive y. This is positive x, negative y. This is negative x, negative y. And this is negative x, positive y. So if I write them out for you. This is x and y. This is x and negative y. And this is going to be negative x and negative y. These are the 4 quadrants. Okay, so next we've got the distance between coordinates. So if a question asks you to find the distance between these 2 coordinates, what we're going to do is we're going to draw a straight line between the 2 points. And what we're going to do is construct a triangle to demonstrate how far apart they are. So if we think from left to right, we've gone 3, and from up to down, we've gone 4. What we're actually trying to work out is the hypotenuse of this triangle we've just made. We know this is a right angle because 2 straight lines have met at perpendicular, so we can work out the hypotenuse. So what we've got is a squared plus b squared equals c squared, which in this case is going to be 3 squared plus 4 squared equals, let's call it c. We don't know what it is, but it's going to be c squared. So this is going to be 9 add 16 equals 25. And so the root of 25 is going to be 5. And so our answer for C is 5. And so I will replace that here. And so our distance is going to be 5. This is a classic 3, 4, 5 triangle. So you might have already known, but just wanted to show you the method. Same for the red one here. We're going to connect these 2 points up like this, with a straight line between them. So what we've got is a 7 here and a 3 here. So we're going to do 7 squared plus 3 squared equals c squared. That's going to be 49 add 9 equals 58. And so the root of 58 is going to be our answer, and the root of 58, if I check it here, so I do 58 and I square root it, I get 7.61. I'm going to leave it as 7.6 to 1 decimal place. But the question may tell you to give it to more accuracy than that. 7.6 to 1 decimal place. Okay, so that is measuring the distance between coordinates. If you see that phrase and you know you've got 2 points, you're going to make a triangle out of them. Okay, so now we've got straight line graphs. We'll start with the fairly straightforward ones. Contrary to what you might believe, a graph of y equals 7 won't be up and down. It'll actually be left to right. So y equals 7 is this line here. And what we're actually saying is that for no matter where we are on this line, y is 7. So here we've got negative 2x, but y is 7. Here we've got 4x, but y is 7. And so our line is y equals 7. Opposite here, x equals 4. So we're going to put a line straight down from here. I'll actually make it blue so you can see which line we're talking about. That's 5. I'm going to move it across. There we go. X equals 4. So no matter where we are on the line, we've got negative 2y but 4x, negative 5y but 4x, and so on. And so we've got x equals 4. This last one, y plus x equals 6. to make our lives easier, if we're not sure how to draw it, I would start and say, what if one of these is 0? Well, if y is 0, then x will be 6. So I'm going to put a mark here. And if x is 0, then y would be 6, because they have to equal 6 when you add them up. And so what we've got is a red line that we can draw like this, connecting the points, and I can keep extending it out into infinity like this. And so we can check our answer and say, well, if it's 0, then it's 6. If x is 1, then y must be 5 to make 6, and so on and so on. And we'll have a diagonal line that looks like this. And so this is our straight line graph for these 3 elements. Where this leads is this formula here, which is y equals mx plus c. And what are the constituent parts of this formula? We've got y, which is equal to the y coordinate. That's what we're trying to find. We've got mx, which is going to be the gradient of the line. So if it's 1x, we're going to have a gradient of 1, and I'll explain what that means in a minute. And if we have c, that's going to be the y-intercept. And in non-math speak, the y-intercept is where it crosses the y-axis. So in the example of y equals 2x plus 3, what we'd have is, if x is 0, then 0 times 2 is 0, add 3 is 3. So I'm going to plot that line here. If we have x is 1, then 1 times 2 is 2, add 3 is 5. If x is 2, 2 times 2 is 4, add 3 is 7, and so on. And what we're going to have is a line that goes like this. We can keep going, so if it was -1, it'd be 1, and so on. And if it was -5, it'd be 10, -7, so it'd be like that. And so we're going to have a line that goes through all these different points, and that would be our straight line for y equals 2x plus 3, with the gradient being 2, so the steepness is 2. The y-intercept is plus 3, which is why we end up with a plus 3 here. And y is whatever we're looking for based on whatever x is. And so that's our equation for the straight line and where it comes from. Now, sometimes you might be asked to complete a straight line graph using a table. And what I'd suggest you do is always start with 0. Because if x is 0, then anything times by 0 is 0. So we've got 0. And then 0 minus 7 is going to be -7. And then we're going to work out just one more, hopefully one of the ones next to it, and we can work out a pattern. So let's do 1, because positive numbers tend to be easier. 4 lots of 1 is 4. Take away 7 is -3. And just to show you, I'll do the next one. 2 lots of 4 is 8. Minus 7 is 1. Okay? Now, you don't have to do all of these, because a lot of these will be worth 2 marks. And the reason why they're worth 2 marks is because there's a trick to do it much faster than having to work out all of them one by one. What we can do is, provided you've got 0 correct, and provided you've got the next one correct, that finds a pattern that we can use to keep going. So the difference between -7 and -3 is 4. And so we can keep adding 4 all the time as we go to the right, because it's going up as we go. So the next one will be 5. If we're going leftwards, we're going to end up with -4, -4, -4, because we're going to go smaller, because this number's getting bigger in the negative. So we're going to end up with -11, -15, -19, like this. And so once you've got this down, you can sort of do these very quickly, just by doing 2 of the points and then working out the pattern of how much it goes up by. And then they might ask you to plot the points. So now we'd go, okay, 0 minus 7. I can't do all of them because they go too far negative, but I can do the positive ones. So 0 minus 7, 1 and -3. We've got 2 and 1. And we've got 3 and 5. And so we'd end up with a straight line that looks like this. 4x is quite a steep gradient, so it makes sense that our line is going way into the sky like that. And that would be our line like this. What would 4 be, is the question you're going to ask. You got 5 seconds. What would 4 be if this is 5? 4 would be 9, because we've added 4 again. That would be 9. Okay? Brilliant. So, next up, we're going to work out the gradient. So, say you're given a line, and you are told nothing else, and you need to work out what the gradient of the line is. We know the form is y equals mx plus c. So what we're really looking for is this part here. What x are we talking about? M is the gradient, but x is the steepness. So to do that, we're going to work out how steep this line is. And to do that, we're going to pick any 2 points you want on the line. I would suggest picking some that line up with the grid lines exactly because it makes it easier. So I'm going to say, let's say 2 and 2 and 1 and 1, just as an example. Then I construct a triangle by doing this and making a triangle out of it. And I work out how far it took me to get from the point I'm starting to the point I'm ending at in the y. So this is 1. And the difference between the x's, so how far it took me to get from where I'm going to where I'm going, is 1 again. And the formula for the gradient is the change in y divided by the change in x. So I'm going to draw a line like this to show it's like a fraction. Change in y over change in x. So the change in y, we've gone 1 down, so it's 1. And we've gone 1 to the left, so it's 1. So 1 divided by 1 is 1. So the gradient of this line is 1. In fact, you may know already that the actual equation of this line is y equals x. And if there's no number in front of the x, we can assume it's 1. So it's 1x, which means our gradient is 1. If I give you a different line, let's say this line here, I'm going to pick just some random numbers. I'm going to go through the origin because it's easier to do. But if I give you this line here, and then I'll extend this out to the extents of the graph, like this, and I tell you to work out the gradient now, what I would do is I'd pick 2 points on my line again, hopefully where they cross over on the grid lines. So let's say 6 and 2 and 3 and 1, like that. I make my little triangle. I work out how far along I've gone, which is 3 and 1. The change in y therefore is 1. The change in x is 3. And so my gradient is going to be a third x. And we can test that by looking at our other numbers. Is a third of 6 2? Yes. Is a third of 3 1? Yes. Is a third of 0 0? Yes. And so we can check that and keep going along and making sure it makes sense. And our gradient in this case is a third x. Now, if I give you a slightly different one to explain a point that's very relevant, I'm going to go like this. Like this. This is my line now. So again, I'm going to pick 2 points. I'm going to pick this point here, and the next time it crosses over the grid lines is here. So my change is going to be 3 and 1. So my change in y is 3, and my change in x is 1. So you would think the gradient would be 3. However, you have to be careful about which direction the line is going in. We count this when we go rightwards. As we go right, does the line go down or does it go up? If the line goes up, then it's going to be a positive. If the line goes down, then it's going to be a negative. So our answer is actually minus 3x. Our gradient is negative 3. We're going downwards. So it's a very steep, or fairly steep, downwards slope, or downwards line. So we're going negative 3 in this case. So be careful about the direction of travel the line is going in. We're going, as we get higher in x, our number is going lower. So it's a negative gradient. So that's one thing to be careful of. Okay. Identifying a parallel line. In the case of y equals mx plus c, parallel meaning 2 lines that go in the same direction and never ever meet. To know that a line is parallel to another one, all we're looking for is our gradient again. If the gradient of both lines is the same, for example, y equals 2x plus 4, I will draw this over so you can actually see it, and y equals 2x plus 8, it doesn't matter that our intercepts are different. What matters is that our gradients are the same. They're both 2. And so that means that they're going to be parallel with one another. So if you get asked to identify whether 2 lines are parallel, look for whether the gradients are the same. And they have to be the same in every way. Just because if this one's minus, for example, they are now not parallel. They would actually be perpendicular. But if they're the same and they both have the same sign in front of them, then they are parallel. In the case of these 2 lines that I've got drawn here, they aren't actually 2x, they're different. I've got the line y equals x here. It's a nice easy line, so I like to use it. Which other line is parallel to that line? Well, it's the red line. We've got the red line. We can you might be able to visually see that. If you can't visually see it, I would work out the gradients of each one and see if it's the same. So let's say this is 2 and this is 2. 2 divided by 2 is 1, so the gradient is 1. Here, the coordinate is 2 and minus 5, and the next one is 1 and minus 6. The difference between the y's is 1. The difference between the x's is 1, so 1 over 1 is still 1. And so the gradient of both of them is 1. That tells me that they're parallel, and I need to do no further work whatsoever. This one is obviously not parallel just by looking, but in case you wanted to know what the gradient of it actually is, 2 divided by 1 is 2, so the gradient is actually 2x. This is the line y equals 2x instead. And so to make a line parallel to this, all I would have to do is make one that's the same steepness and move its intercept anywhere I want. So in this case, let's move it up here. The intercept is now 4, and I extend this out. Then this would be a parallel line, but it's y equals 2x plus 4 instead. And that would be a parallel line to that one. Okay, moving on. There are two scenarios in which we may have to find an equation. And one of the first scenarios is when we get given 2 points, but no gradient, and we're expected to find the gradient. So the first thing I would do is mark the points on my graph. So I'm going to go 3, 1, and minus 6, minus 2 is down here. That's my 2 points. Now, you may be given this with no graph paper whatsoever. So if you have no graph paper, you'll have to use a different method, but if you are given graph paper, then I would actually draw the graph and measure them. So I'll do it with graph paper first because it's easier, and then I'll tell you how to do it if you don't have one. So here we can see the equation of the line passing through these points. I can work out the gradient. It's 1 downwards over 3, so we're going to have a third x. And I can see the y-intercept is nothing, so my line is just y equals a third x. That's my line. If we don't get the graph and we can't just plot the points, what we would do is the change in y over the change in x. So how do I get from 1 to minus 2? There's a difference of 3. And how do I get from 3 to minus 6? That's a difference of 9. So we've got 3 divided by 9, which when we simplify will become 1 divided by 3. And so that is our 1 over 3x again, but now without any graphical knowledge. To find the intercept at this point is a little bit trickier, but we can do it. We've got our 1/3 x. So we know that the form for a straight line is y equals mx plus c. And I know that an x is a third. So we've got y equals a third x plus c. And that's all we know so far. But we are given some of the points. So in this case, we know that 1 is equal to a third of 3. So a third times by 3, add c. What is a third of 3? Well, a third of 3 is 1. So 1 equals 1 plus something. What must be the something? The something must be 0. And so in this case, that's how we get back to y equals a third x plus nothing, which could be just written as y equals a third x. And that would be the answer to that one. Another kind of question we can get is when we have a gradient and 1 point and nothing else. So we could say the gradient is 2 and the line passes through point 27. So again, I'm going to, even if you just sketch it out, I would sketch out a graph because it makes life a lot easier. We have the point 27. And we know that the gradient is 2. So we know straight away we have y equals 2x. Plus something. We don't know what the plus something is, but we can work it out. So here, we're told that 7, and I'm going to leave this here, 7 equals 2 times 2 plus c. 7 equals 2 times 2 plus c. And so what is 2 times 2? Well, I'm going to put that down here. 2 times 2 is 4 plus c. So c must be 3. And so y equals 2x plus 3 is our answer for the equation. If you're not allowed to use a graph. If you are allowed to use a graph, what I might do is I'd say, okay, well, what is the y equals 2x line? What does that look like? Well, at 0, it's 0. At 1, it's 2. And each time in the x, I'm going to double the number. So 1 equals 2, 2 equals 4, 3 equals 6, and so on. And I could keep going into the edge of the graph again. So 3 is 6, 4 is like that. So that's my line. That's y equals 2x, the line I've drawn. this point is in line with this point here. So how do I get from here to here? I have to go up 3. So it must be add 3. And that's another way of doing the problem as well. But if you're not allowed to graph, replace the formula y equals mx plus c with the coordinates you've been given, and then find the other answer based on that. That's how you find c. And thanks for watching.